Hi everyone, welcome to another fantastic night of physics videos. And today we're going to look at our very first kinematics equation. Yeah. Now our first kinematic equation. All of these equations are going to be based on constant acceleration. That's all we do this year. We never do anything other than constant acceleration. So if you look at the acceleration time graph to the right, you will see a flat line or zero slope acceleration. That in turn can result in a positive slope for a velocity on a velocity time graph like we see in the middle, or a negative slope if it is decelerating. But we will only work with constant acceleration. Therefore, there is no difference between instantaneous acceleration and our average acceleration.
We're going to simplify things a little bit by making a few changes to our values by considering what our assumptions are. One of which is that we are to assume constant acceleration. The other thing that we are going to do is to consider delta t. And we understand that delta of anything is always t final minus t initial. So what I can do is I can realize that usually I'm going to be working with a stopwatch in physics, and t initial is going to be my zero. So I can just say that the time interval is going to be the time that's going to be on the stopwatch. And I can just call that t. What we also can do is we can also talk about the displacement delta d and understand that delta d is again d final minus d initial, the final minus the initial position. So if our initial position ends up being the origin of our graph, we can actually just say that this is going to be 0. And if it is 0, then we can move on to change delta d to just d, the final position. And then we are going to work with our equation about average acceleration. The average acceleration is going to be equal to the constant acceleration, so we don't even need that average anymore. And we understand the definition of average acceleration will also apply, and that's going to be the change in velocity over the time interval, which I'm now talking about as t. Now, with this acceleration being the same every instant, I can multiply both sides by t, and I can also understand that delta v is v final minus v initial. Adding v initial to both sides is going to give me the final form of the first motion equation, that v final is equal to the initial velocity plus the acceleration times the time. And that is the first motion equation for constant acceleration.
Divided by t, S equals d divided by t. Go. Oh crap, my meeting!
Okay, so the Bugatti has an acceleration of 10.5 meters per second squared. If it is moving at an initial velocity of 14.5 meters per second and accelerates at its full capacity for 3 seconds, what will its final velocity be? I don't know.
Fine, that's easy. We use our first motion equation.
Final velocity equals initial velocity plus your average acceleration times how long you've been accelerating.
We know the VI is 14.5 meters per second. We know the acceleration of the Bugatti, 10.5 meters per second. And it's been traveling 3.00 seconds. Let's just do the math. Why meters per second? Because meter per second times 3 seconds. Seconds cancel out. Meters per second. A velocity plus a velocity. Initial plus added from acceleration. And our answer is 46.0 meters per second. That's really fast. That's over 100 miles per hour. Hi.
Dad, what are you doing?
I am doing physics.
Why are you talking like that, Dad?
I'm doing physics. It's my German accent. German scientist.
That doesn't sound like filming.
Okay, Poppy's, Daddy's working here, David.
Let's do another one. Duck hunter accidentally discharges his shotgun straight up in the air. We'll call that plus direction with the birdshot having a velocity of 300 meters per second. Ignoring all other forces, we know that gravity will be acting on the birdshot at minus 9.8 meters per second squared. That's going to be the acceleration. It takes the hunter 4 seconds to gather his wits and react. At that point, what is the velocity of the birdshot? Is it heading back down yet?
I do sound, that is a German accent. That's it. Oh, hello there. Let's do the next one.
Again, our first motion equation, we know our VI is positive because it's up in the air. Oh, what a fool. 300 meters per second. We know our average A because of gravity, pulling it back down, minus down, positive up, minus down, 9.8 meters per second every second. And it's been traveling 4.0
seconds. Let's just do the math.
That's not the dumbest accent.
300 meters per second plus minus 9.8 meters per second squared times 4. So it equals plus 300 meters per second plus
260.8 meters per second.